Fantastic. It's great to be Plan B. Um, it's a talk that has been in my head for a while and scrambled to put some quality, hopefully quality content together to match the audience here. Appreciate everybody taking a look and listen, and great to meet everybody. My background is in mathematics. I've had the good pleasure of doing data science work for the last 30 years in a number of different capacities. I'm also an inventor and a founder. And so I want to talk about climate tech and the future of the planet. Like, that's a bold title. We'll see how well or how far we get into it, but this is just a survey. But I'd also like to talk about conservation labs and our role in it, and a bit about our story. And hopefully you find that a bit not just interesting, but maybe in part educational, and hopefully an ounce of inspiration as well. And then do want to get into some of the technical aspects of what we're doing, because I think you'll find that interesting as well. So I may actually have 3 talks here instead of 1. We'll see how far we get through it. When you look at the planet, there's really, in my opinion, 3 different perspectives on where we're heading as a species, as an ecological system. There's the doom and gloom folks. There is the technology will save us folks. And there's the camp that I fall into, which is one in which I see humans playing a significant role in our future, not to the detriment of the planet, but to the future of the planet in a hopeful perspective. And so the theme of this is really towards the latter, but of course we are talking about climate tech, but it's climate tech to the needs and the use and the innovation of folks like yourself. So when you look at that perspective, it is actually an ancient perspective. There's ancient writings, there's ancient Hebrew writings, when you read them from well over 1,000 years ago, that there are themes about our relationship as humans with the planet. And those 3 themes are consistent across cultures, across time. Those themes are around responsibility of the community, that we are kind of wired to actually safeguard our creation for future generation. And then the 3rd theme, and it's an important one as well, is that we do these things in service for each other, but also with a special care for the poor. And so when I look at the future, it's these themes that have been around for millennia that give me hope about what the future of the planet looks like. And I kind of put this into a checklist, right? So there's a checklist when you look at these things on a personal level. It's how do we take special responsibility over the earth and over each other? That is very, very tactical. And then it gets a bit broader than that, because we need to do that, and we need to act with wisdom and with reverence on the resources that we have in nature, so that no one would suffer from their use and actually benefit from their use. And then ultimately, all of these things help us to sustain the planet for future generations. It is a big to-do list. And so that taking responsibility is really the first step, and kind of thematically where I would like to go with the rest of this talk. So I am a startup founder. So I do startup speak, and I am a consultant in previous life. So I do consultant speak. So when I looked at assessing the future of the planet, I kind of use these 2 frameworks, and I'll go through them a bit quickly here. So startup speak. When I talk to investors, one of their favorite questions is, what are the tailwinds, Mark? What are the headwinds of the industry that you're in? And so I cheated. I asked ChatGPT, like, what are the tailwinds and headwinds of the planet? I got some fantastic answers back. And by the way, when you look at headwinds and tailwinds, I often, there's this picture that I get of crosswinds, and that's the life, or that's the area in which I tend to live, is in the midst of these crosswinds. So we have this anemometer as part of those investor meetings. We are startups, so it is kind of a homegrown anemometer, but the idea is measuring those crosswinds and headwinds and understanding where we're going. And then that's also what ChatGPT has helped me with. So look, this is not anything that you probably haven't heard before in terms of the headwinds that are forcing or going against kind of the planet, against our future. And certainly climate change is at the top of that list. But there's also significant issues around population growth. There's certain parts of the world where the population growth is very significant, and resources are already strained. And so we need to address the availability of those resources, but also we're pushing biodiversity loss. Those three themes are consistently what you see across literature, across governments, across mandates, et cetera. But we also have a lot of tailwinds, the things that are pushing us forward. And the biggest one, of course, is the technological advances out there. And I'm going to talk about a number of them and even give some examples. And one of those technological advances are the energy transition. There's some amazing work that's going on in everything from solar to now nuclear energy. And so we'll touch a little bit on that as well. So there's something missing with this, though, and this actually comes back to where I started the talk, when there's something missing in all of this. And I turned to Doctor Who for an answer. This is one of my favorite quotes from Doctor Who. My experience is that there's, surprisingly always hope. And so when you look at all of the tailwinds and headwinds, there's something about the human spirit that is missing from that equation. And I don't want to get into a big debate about who the best Doctor Who is, but I think we all know who that might be. The last thing, of course, is this human spirit. And this issue of human spirit, it's hard to put a definition around. And as I was thinking about this, it's really odd that when folks talk about the human spirit, they start to ascribe to the human spirit things that aren't human. And one of my favorite ones is resiliency. Resiliency is actually about rubber and tires and things like this. And so somehow in the last 100 years, we've decided that humans are like tires. Another example is empathy. Empathy is a word that only has existed for the last few hundred years. And it kind of says like, hey, because I'm like you, I will care for you. But I think humans are bigger than resiliency, or bigger than empathy. We have the capacity to hope. We have the capacity for faith. We can show compassion. We can show love. And those are like squishy things for a mathematician to talk about. But I think when I think of the human spirit, those are the types of things that I think of. So it comes back to these issues around responsibility and future generations and being in service. But then I did a consulting exercise as well. And my favorite consulting exercise is a SWOT, right? So strengths, weaknesses, opportunities, and threats. And so I didn't hire a big consulting firm, didn't spend a lot of time on this. I asked the robot about what is the SWOT for the planet. And I got some great answers back. And ones that we've consistently heard and I consistently talk about as well. And you look at these strengths, awareness, I see, is certainly a strength, but I'm getting tired of awareness. I want to see action, and we'll talk maybe a little bit more about that, but you cannot ignore the advancements in technology. There is a growing adoption of renewable energy sources, and cooperation is probably at an all-time high. I have the privilege of going to Dubai in a few days to talk about sustainability and water, not just with the government in the UAE, but with a number of property developers, utilities. And it's the year of sustainability in the UAE, in part because COP28 is going to be there later this year, rather. But the point in mentioning that is there's increasing cooperation across governments as we look at the importance of this for the planet and for future generations. But of course, there's still weaknesses. We still have a number of unsustainable practices. The lack of will and action is a painful one for me. And that goes back to awareness. Like, there's a growing awareness, but that awareness actually has to affect change. That awareness has to drive action. And of course, consumption levels and related to the lack of will is resistance to change. But there are a number of opportunities. And the biggest one, in my opinion, is around innovations and technology and what is available to do today and where the future is going. And then, of course, the threats that are out there, and I've already mentioned some of them around biodiversity and scarcity. With water, where we play a particular role. I love to talk statistics around water. I could be really quite boring at a social gathering, but hopefully a few of these are interesting to you. I'll actually just give you one. up to 55% of the continental US is in a drought at any particular time, in any particular 1 month period. That's actually really quite stunning because we think the droughts are focused on the Southwest, but those droughts are happening all across the US at any particular time. And so water scarcity is actually increasing quite a bit. And that scarcity, whether it's water or other resources, is causing instability. And so that is certainly a threat as well. So I just like to package it all together in one slide. That's what it looks like. But again, there's something missing with all of this, although it's inherent in all of it. And that's who's doing the work: individuals, organizations, government, people. And when you look at actually this list, I'll flip back to it. Everything on this list except for one item has to do with people. And of course, the one thing on this list, where is it? It's the natural disasters. Now, indirectly, perhaps related to people in terms of cause, but it's the one thing, whether that we can't control. But everything else on this list is in our control. But when you look at all of these things from individuals, organizations, the reality is it's all about people. Just like Soylent Green is about people. And so when I think about people, I did my own little analysis on this, didn't rely on the robots for it, but there's a ton of threats. Actually, I got kind of bored of writing all of the threats, from greenwashing to us being distracted, pollution, and action, war. Now we have to add bank failures on top of the pandemics. By the way, what a terrible time to be a startup. Actually, that's not entirely true, because in all of these things and all of these threats, the opportunities are actually significant for the right companies, the right ideas, the right products, the right people. But there are weaknesses, and the biggest one already touched on is this unwillingness to change. But there's opportunities as well. And the best way I can articulate the opportunities from a startup and a founder perspective is there's opportunities for unicorns. We joke that we want to be the first narwhal, the first water unicorn in the world. And then the strengths. I mean, it comes back to the human spirit and this aspect of what we have the capacity to do, and the capacity to see and believe and innovate. And so again, just bringing it all together in the planetary SWOT. ClimateTech. This is where we have a significant opportunity as scientists and engineers, mathematicians, to focus on the innovation and the technology. I have a different definition of climate tech than you'll see in the marketplace. The marketplace tends to talk about climate adaptation and climate mitigation, but I really look at it as the technologies and innovations that are designed to help us be better stewards, to sustain future generations. I don't think we should do these things. We should innovate, that we should be focused on future generations because we have to adapt and because we have to mitigate. And certainly those things are true, but even if we did not have to do it, climate tech should be a thing. We should be better stewards. We should use the capacities and gifts and abilities that we have to improve the planet for future generations. So there's a number of climate technologies out in the marketplace, and there's about 8 sectors, and I'm not going to go through all of these, but there's a few things within this that I wanted to mention and just make a point of, because it is growing. And there's a reason. There's always a KPI, there's always a metric, and here's another group of them as well. And we happen to be at Conservation Labs all the way on the end there, in the built environment at the bottom of the list on water. This isn't my list. This is kind of a standard list that's used. I think I got this one from PitchBook. But there is a KPI with all of this, and that KPI is carbon neutrality. There is in effect, a global goal to have net zero carbon dioxide emissions by the year 2050. And that means we're eliminating as much as we're producing in terms of greenhouse gases. So we cannot not produce greenhouse gases. I'll give you another statistic. Water itself is responsible for as much as 3 gigatons of carbon or greenhouse gases or carbon emissions. And to put that in perspective, that could be anywhere from 5 to 8% of carbon emissions are with water, and you kind of have to have water. So this can be achieved by balancing those emissions and eliminating the emissions as well. And when you look at some of these different types of climate tech, just to put this in perspective, and I jump back a slide here, electric transportation is like half of all venture capital investments are going into electric transportation right now. The next highest one is food systems, which is over on the left there at 13%. And then in the built environment in which I operate, it's only 2%. But get this, the built environment is responsible for 41% of carbon emissions across the globe. It is the single largest driver of carbon emissions. So we have to do better and we have to do more there. And investments coming just across the board. To put it in perspective, there were $82 billion of investments in climate tech in 2022. And to put that in perspective, that's a 20% increase over the prior year, and it continues to grow. Now, there are significant headwinds. Of course, you're familiar with the issues with SVB, with Silicon Valley Bank. What you may not know is Silicon Valley Bank is essentially a climate tech bank. And so that has created quite consternation for folks like ourselves. We don't happen to bank with them, but a number of my colleagues and friends do, and we're had a rough weekend, and I think we're all going to continue to have some rough waters here in the upcoming days or months. So I wanted to give you some examples. Block Power's here. I had the pleasure of being in a cohort, an accelerator cohort with Block Power last year, and got to know these guys. I picked I don't know, 6 or 7 that I wanted to just share a little bit of detail about. And what this is who they are, where they're working, what they say about themselves, and why I like them, all the way to the right-hand side. And with Block Power, I think the biggest thing is, they're not manufacturing something. What they're doing a fantastic job of doing is taking those solutions that are available in the marketplace, but combining clever and unique financing and engineering and project management, so that folks that may not be able to afford or otherwise have access to ways to reduce their energy consumption. So there's cost savings, but also carbon impact. So they're serving those that are with the most need. That's why I like these guys. Burrow, this is neat. I mean, how could you not like robots on farms? So they do a lot of clever things with this robot. You can tell there's a tray there, so they're moving it around, but they also act as guard dogs, and they're counting fruits and vegetables as they pick. They're reducing the requirements on human labor. But the other reason I really like them, when they're doing all of these things, they have all of these metrics that they collect. So even if you look at their website, you'll see spreadsheets on there looking at kind of before and after. So that's kind of cool. I really like what they're doing. Divirod, fantastic group of founders. I met Adam through Techstars, where we were both part of, and he has kind of a famous background. He invented a robot, and it showed up on Star Wars, if you're familiar with BB-8, but he put that all aside to focus on Divirod. And what they do is digitize water across the globe by using sensors and satellites. And so they can deploy their solution in a reservoir and track it, but they can also deploy it in a cornfield and essentially estimate the embodied water in that cornfield. And so why is that important? It's important from everything about understanding scarcity and cost and demand management to risk. So that's near and dear to my heart around digitizing water. And of course, all of this has to come together. Measurable is probably the market leader in taking all of this disparate data and combining it in a way that in the built environment in particular, that you can understand what the opportunities are with sustainability, from carbon emissions to all aspects of carbon, water, energy, etc. Mill, this one's interesting. A garbage can for $40 a month. I'm not still sure what I think about this, but I love the fact that they got a $100 million investment with no sales. It also helps that the founder of Mill was the founder of Nest and has quite a track record of success. That's Matt Rogers. And so they are selling a garbage can for $33 a month, probably about another $5 or $7 a month in energy costs, so that you can turn your food waste into chicken food. I like that. Again, that they got $100 million for that. Simple. When I learned about Simple, and they're a partner of ours, I was like, you guys are hacking the electric company. I got so excited about this. And apparently this is a thing. I didn't know it was a thing. But the way you're billed from your energy consumption is a kind of a constant rate, but then there is you're billed on the peak rate over like a 15-minute increment. And so when their technology sees that rate coming up, they start shutting down equipment. So if you're in a restaurant, they could shut down the freezers and the washers and anything that's driving that electric consumption. But then, of course, you have to have sensors that are watching the humidity levels, the temp levels, make sure things stay safe, and they turn it back on. And so this becomes not only a way to hack the electric company and save money, but you're also saving energy as well and reducing carbon. And you can't ignore what's happened with the Department of Energy at the Livermore National Lab in California, where they've successfully produced this nuclear fusion reaction. And of course, the reason why that is that it's a net energy gain. And so this has been going on for decades in terms of research. Now, where they are now, they can boil about 10 kettles of water with that massive machine. I have a microwave that I think can do the same. So there's a long way to go, but this is where I think of flux capacitor and time travel, but of course, super cheap, low energy, cost energy for the future. You're looking at decades out for sure before this is commercialized. So that's a good overview of a couple that I like. I just wanted to give you a review of that. I'm not gonna review this slide, but I just wanted to emphasize when I said there's $82 billion out there, there are a number of venture capital funds that are pushing that work forward. And these are folks that are likely have funded most of everybody on those prior slides, not all of them. Some of them are actually bootstrapped like Simple, which is amazing, and super hats off to them. And I think I've spoken to about half of the folks on this page as we're raising our Series A investment. So offline, I can tell you which ones I really like and don't like. So how did we start at Conservation Labs? And this was my water bill from back in 2014. And you can see towards the end there, it doesn't take a mathematician to see that July and August look a little high. So when that water bill came in July, I thought, well, I have a rogue lawn water out there. Maybe one of my kids was using the wrong spigot because we have a cistern in addition to the municipal water. But then when I saw it again in August, and that's probably about $50 a month, maybe extra. When I saw it again in August, I thought, okay, something is wrong. I must have a leak in the system someplace. So I started inspecting the pipes and make a few weeks of kind of poking around and inspecting. That's my furnace system, or that's the pipes above it. And you can't actually see it in this picture, but where there's a valve there kind of to the bottom left, it's called a pop valve. And what was happening was, this was in the middle of August, and I have this old boiler system in an old house. My house goes back to the 1850s. And what was happening is that the pressure was building up, the pop valve was bad, and I cleverly put the drain, I put the pipe instead of onto the floor right down the drain. And so I never saw the water loss. And so I looked in the market to see, well, goodness, that could happen again. It could be something else instead of the pop valve. And I looked out on the market at the time, and all of the products that were available were well over $1,000. In other words, products that would monitor my water use and identify a leak and alert me of this. And keep in mind, this is back in 2014. There was one product that would do that. It was $1,500. It was massive, and you had to hire a plumber to install it. So I thought there has to be a better way. And there's a few things going on at that time. That's not me, by the way, on the picture on the right, but over the next several months, I was just, as an intellectual curiosity, thinking about how could I solve for this. And I started researching some things, just online research, and I saw folks were doing ultrasonic, and that looked really tough and expensive. And I was remembering my sister had this stereo growing up that had flashy lights on it when the music played, and the lights would dance around. And I don't think it was that stereo. I don't see the flashy lights, but that was the closest thing I can find to what I remember it looking like. And I thought, well, that must be generating data. So sound must generate data. There's this thing called the human audible sound range of frequencies I knew about, that was about the extent of what I knew about it at the time, but thought maybe there's some data there. And then, if it was a month later or a day later, there was a leak in an outside leak in the pipes, there's an outside leak in the alleyway behind my house. And I called the water company, and they came out with a tool that looked like that. It almost looked like a divining rod. And he had the earphones on, and he was poking around the ground. I'm like, dude, what are you doing? He's like, well, I'm listening to see if I can hear the water flowing in the ground or in these pipes. I'm like, well, that's interesting. Sound data. Maybe there's a way to use sound. Microphones can't be that expensive. They're in everything. And that might be a way to get to something. In my mind, a product would be about $100 to detect water use and water flow. So that was the idea. Can I create an algorithm that can convert the sound of water to a water flow estimate? So I started running experiments. And the first thing to do is I had to find a way to collect that data and log that data, which I spent more than a few weeks figuring that out and finding it. And I found this device that is used to monitor the sound in construction zones and work zones. And so I rented it. It was like a $3,000 device. I convinced somebody to rent one to me for a few $100s for the weekend. And I just spent the weekend flushing the toilet, filling up buckets with my stopwatch, recording and logging the data, and it created this huge known data set from all of this data from doing that for a weekend. And then I wasn't doing analytic work at the time. I was not hands-on analytic work, but I was working with an analytic company doing other things. And so I had to go find some software to do it. I don't remember what it was, but started building algorithms, and lo and behold, I got an R squared that was 98%. All right, well, that's kind of geeky. You're not going to build a product or a company on an R squared at 98%. So of course I did some other things, looked at statistical measures, did some out of sample testing. And then I had my good friend, Paul, who's a PhD in stats, like look at all of my analysis. I almost wrote it up like he was my professor. I sent it off to him and he validated everything like what's right. So I'm like, hey, there's this idea. I can convert the sound that this thing makes to a water flow estimate. But there's this joke out there, and you may have heard it. An engineer is working at her desk and a fire breaks out. And that engineer looks around, sees a fire extinguisher, grabs it, puts out the flame, and goes back to work. And then there's a physicist, he's working at his desk, same thing happens. He looks at the fire, he looks at the fire extinguisher, and he's thinking, well, fire requires fuel plus oxygen plus heat. The fire extinguisher will move both the oxygen and the heat from the fire, ergo, no fire. And so he grabs the extinguisher, puts out the flames, and goes back to work. And then the mathematician is working at his desk. He's in another office, but he's seeing a fire. There's fires breaking out all over the place. I don't recommend working at this office. He looks at the fire, he looks at the fire extinguisher, and he thinks for a minute and says, a solution exists. And then he goes back to work. And that's the problem with mathematicians. Once we solve the problem, even if it's in our head, we just go back to work. But for me, there was something different about this. I had happened just to, at this time, also did a 3-week tour out west with my family, and just saw firsthand what the drought was doing. Like water was turned off in our national parks. There's bonus points if anybody knows where this picture is taken from. It was one of my favorite hikes. It was definitely not this green when we were there. This is not my picture. But when I came back from that trip, I was really convicted that this was a problem that was worth solving. And so I also had a heart for conservation and a passion for these issues at a very personal level. And this combination of complex math problem, having an opportunity to actually make a difference was really appealing. And that's when I don't know why I did this first, but I was like, somebody else is gonna get this idea. So I got to file a patent. That was the first thing I did. So to do that, I was ready to quit my job, but I was working 3 jobs to pay the patent attorney and to pay for other bills that started coming up at that time. So patents take a long time. So we're also practicing patience. But then I started pitching and building and looking at things out there. And if you were in line with me at Starbucks, I was pitching you about this idea. I was just getting feedback from anybody that I could find. We even won a few contests. I think in 2018, we were the CES in the innovation category for climate change. We actually won. And I think I had a block of wood at the time for a sensor. It worked, but it wasn't even IoT enabled. But I was just listening and talking to as many folks as I could at that time. And then in 2018, so this is 4 years later, we were very fortunate to be invited to an accelerator with Amazon and Techstars. And that really just opened up my understanding and ideas to what it meant to be a venture funded startup in particular. And there was a lot of learning, a lot of networking, and a lot more pitching and getting better at it. So that's the quick backstory of how Conservation Labs got started. I want to spend the next 15 minutes, like 5 minutes kind of going through who we are so you understand that, and then maybe 10 minutes talking about some technical challenges. So I like to joke, these are 4 prime numbers that are going to help solve the climate issues and help us be better stewards. So we waste in the US 5 trillion gallons of water. To put that in perspective, that's enough water to meet the needs of nearly every home in the US every year. And I already mentioned that carbon from buildings is amongst the highest, or is the highest carbon emitter. But water is actually the second, in most commercial buildings, is the second largest consumer of energy. So our thesis is, if you're not solving for water, you're not solving for carbon, you're not solving for net zero. But there's a huge cost to this as well, right? So there's a cost to the planet, but there's an economic cost. And this is also what matters to the investment community. They're not completely altruistic. Actually, they're not altruistic at all. So there has to be a market here. And this market is that we're solving a $100 billion problem. That is the cost of that unwanted water use just in the US. So when we look at that, there's only 4 ways to reduce unwanted water use. We're going to either reduce human consumption, we're going to reduce the inefficiency of systems, we can identify those common leaks, where we can avoid catastrophic leaks. You'll notice that there's a note on here, and this is a pet peeve of mine, is that Pittsburgh, where I live, is amongst the highest water rates in the world. I mentioned I'm going to Dubai. We're twice the water rates as Dubai, and it's a desert. They get most of their water from the sea, which is really expensive. And I can actually see, you can't see it in this picture, but I can see the river. I was standing on my roof when I took this picture. That hill on the other side is the other side of the river valley. I could see in the winter the river, and I still have some of the most expensive water. And literally, they take that water out of the river just below my house. So there are, at that time now, I mentioned one solution, and there are now, we're tracking like 30 solutions. And why is it important? Why are we different? And the issue is that so many of those solutions are really, really quite expensive, still hundreds of dollars. They still are hard to install, or they don't offer significant resolution in the data. So we invented a better way to do that. We cracked the code with this first product of ours, H2No. So what we are doing is listening to the sound of water flow in a pipe and converting that sound using machine learning. It's pretty intense. So that's a simple picture of it. If this was in your home, by the way, it would just take one sensor. Now that building on the right, or that picture on the right, is a 30-story building in Manhattan. You can see there's a string of sensors on all the cold risers and all the hot risers. So you do need more sensors for a large building. But we can tell you exactly how much water is being used down to the second, and tell you if this is in your house with that one sensor, how much of that is the shower versus the toilet, the faucet, et cetera. So it creates high resolution data that drives impact. And this is just a picture of that. So what we're doing is detecting leaks. We're creating this water awareness. We can craft these custom conservation recommendations. When we're in multifamily, we engage with the residents. We're seeing fantastic results with that. In some cases, people are reducing their water consumption by 36%. In low and mid-income families, and we're in some public housing with that, that's meaningful. That's like a month's rent for some folks. Over the course of the year, they save a month's rent. So there's meaningful savings, and there's meaningful carbon impact with all of this. If this was in a large property, we would be not just in the domestic supply, but in irrigation and building systems. Just to put this in perspective, our solution would cost that large building. Now we retail that sensor at $129, but for a large building, there's going to be many sensors. In this case, 200. So there could be as much as a $30,000 one-time fee. But this is really the important thing, is that fee and those annual fees create a ton of value. And so this is all about reducing water use and creating that value. And this is just from utility savings, water, waste, and energy. And you can see actually the energy savings is 44,000 is higher than the water. But most importantly, from a climate impact perspective, we can do that and create value. We can do it economically. We can create business value for the property owner, but we're also reducing carbon emissions, in this case, like 100 metric tons, which is really quite significant. We're doing that all over the globe, from LA to New York City. We're at the Hall of Fame Village in Canton. We're in some castles in the UK and some high, luxury hotels in Egypt. So we're just getting started. We did about 5,000 sensors last year, and continuing to grow and move on. So this is the team. It's a little bit about us. And in the remaining 10 minutes, I just want to jump into, and I probably could talk about this last thing for quite longer, but again, give you a survey of a little bit of the problem here that we're addressing. So there's a phrase, right, that says, it's like doing a startup or doing innovation is like building the plane while flying it. We think we're like building the rocket ship while flying it with that level of seriousness and intensity. Fun to think about. Now, reminder, when I got started with this was the tech stack. I was using Google Sheets, some free machine learning package, and a block of wood and some duct tape. Now, of course, I had rented the machine that I had the block of wood and duct tape that I was using to connect to the pipe. But that was how the tech stack started. But that gets us part of the way there, right? It's validating that something can happen. But from an analytic perspective, we need to build something that is accurate within 5% of the fiscal meter. And I can talk about why that is, but we feel like that is the right service level. We want to classify that water use, tell you everything that's going on down to the fixture level, but we do have some tolerance for the unknown. So we'd like 10% of it to be, no more than 10% be unknown. And we need to identify leaks, and we need to do that within minutes. But also from a user perspective, this all has to be completely frictionless. This has to be self-training. We don't want the user to have to code anything in. We don't want to have to run the faucet like I did when I was collecting all that known data. We have to do this 5,000 times a day to have a significant business. And so that is the biggest challenge, and where actually all of our IP is wrapped into, is self-training thousands of sensors a day. And we're not there yet, and I'll show you a little bit about where we are. And just to put this in perspective from a data perspective, when we use this sensor, all it's doing is collecting sound data. It's actually doing thousands of measurements every second. There's 86,400 seconds in a day. That data is pushed out. There's about 100 dimensions that are pushed off of that from those thousands. So already this is a massive amount of data. When you go through the data engineering process, that's going to explode to order of magnitude 5,000 dimensions. We're running 11 models for every second, and then that generates 5 dimensions-ish in the end. And we're doing that every second of the day, day in and day out, for every sensor. And so there are a massive amount of data transactions that are happening through this. I just wanted to give you a sense of that. Now, when we do that, we're doing that for one sensor. And today I said where we want to be and where we are, we can do about 15 sensors a day today. By the end of next quarter rather, we will be at about 50. To do the math on that, we're going to sell about 30,000 sensors this year. But then we need to go to 100. Then we need to go to 300 sensors a day, 1,500 sensors a day. It's a massive engineering and data science problem that we're working on. But here's the other cool thing. We're doing that for water, but we think we could do this for other use cases. In fact, we already are. We're condition monitoring machines. So I could tell you with that same sensor in a machine, if there's a bad belt bearing, spring, an unbalanced load, and other factors, all with that. So we want to do that multiple times for multiple use cases. So that's the problem that we're solving. Now, when you look at the tech stack here, and this gives you a bit of a picture of it, we are using a fairly simple device on the edge. We're using AWS as our platform. Everything in and around IoT services are pretty much coming out of the AWS stack. And this is also where fleet management happens, where we're tracking and what's going on. That is being pushed over to the machine learning side. There's a number of aspects of that, from insight development to processing. And then, of course, the storage size. We're dealing with a massive amount of time series data, which I've only dealt with, a hair in my past life. So this is a bit of a different structure in terms of how we do that. There's a lot of clever strategies my team has put together in terms of how much data we have and retain, and where it goes, and when it moves to a glacier versus processing, and then ultimately all this has to come out in an application. Crazy thing is, and I didn't emphasize this before, is that after all of that data that is generated, those thousands of sound measurements, at the end of the day, if this is in your house, there's only 100 rows of data because you use water about 100 times a day. But there's an application, of course, then that you can see all of that. All right, so I'm running a bit short on time. This is in the deck, you can see it, but I'm not going to go through all of that detail on the product architecture. From a KPI perspective, I think this is important, is that when we saw those numbers and we knew what we needed to do, I created a KPI for the team, which was just this general number of sensors trained in one day. We need to track that. Well, that's a terrible KPI because there's nothing specific about it. So then I thought, okay, we need to have a number, did the math on that, fairly simple to do. And so then it became, our KPI is training 15 sensors in one day. Well, it turns out that that's also kind of a terrible KPI because there's no time frame in which that happens, and we kept just missing it. So now what we do is we're tracking the date in which the team believes we can train, actually this should say 50 sensors now, 50 sensors a day in one day. And because what we're doing, every time that slips, we have to understand why that data is slipping. This is absolutely the most critical thing for our growth, and where not only our IP is, but where most of our R&D is to significantly extend and scale the system. So the KPI we use has the date and not 15, but 50 sensors in one day in terms of automatically training, going straight through this really complex process. What does that look like? Just a hair on what that looks like. I mentioned there's 11 models. This is the 5 categories of models that we do. So all of these things are happening at once. We have to determine if there's an event that we like and are looking for. Is it a water event specifically? Because there's this complex issue around sound and noise. So we see other events out there, and they could be water events, or they could be movement of water, but not usage of water if you have circulation going on. We cluster everything. There's a certain using unsupervised clustering, we try to understand how many unique audio profiles are in that house. Of course, we have to classify it. Is it a faucet? Is it a sink? Is it, that's the same thing. Is it a toilet? Is it a shower? How much flow? What is the rate of flow? And what's the likelihood that that event was a leak? So we have KPIs with all of those things because those are the models and algorithms that we're developing. So when we do this, and we're kind of a half Python shop, we're moving to be a full Python shop. And the reason is a lot of our early work was very R&D, almost academic. And it's there's other platforms and tools out there that are great for that, but it's terrible at building a product and doing it at massive scale. And so we're migrating portions of code now to Python. And when I asked the team, like, hey, why do we want to do this, right? And because anytime you're moving and transitioning something, there's work involved, there's risk. And the first answer was like, they didn't say this, but what I heard was, well, nobody gets fired for using IBM, right? So Python is best in class for our particular use case, and we need to be there. We're also doing rapid development now. So there's a lot of work that has to happen very quickly and with a growing team. By the way, we're hiring, so the team is growing. And there's a lot of reasons why, from readability to sharing and collaboration to the support that we like. And probably for me, the most important piece is the operations aspect of it, because we need to absolutely minimize the effort that is currently happening when we're building algorithms on the data science side and then migrating that or putting that into production code. That process is really clunky today, or has been clunky, and we're improving on that pretty significantly. But that is going to help us really hit some of those metrics on the KPI that I mentioned, the 50 sensors, 500 sensors a day. I'm going to close off with challenges in the next few minutes. This is more AI. I asked the robot to give me a picture of a challenge. I have no idea what that is, but I like some of the other ones. Biggest challenge is known data. We could collect data in our homes. We could do synthesized or synthetic data rather. We could have tools now to do data collection in the field, but collecting known data remains one of the biggest challenges. So we're actively continuing to innovate on how we get data. Noise is terrible. So on our sensor, there's 2 mics. We do noise cancellation. We need to continue to improve that. There's noisy environments out there and they impact the results. So we are actively developing and working on that. People say hardware is hard. Why did the AI come up with the Bundys? Actually, I came up with this one. I remember Peg Bundy saying, when I put the kids down, they're never where I left them. And I said, when people say hardware is hard, I think of that. Humans are hard. Humans get sick. They have feelings and emotions. We require motivation. So anytime I hear hardware is hard, that is true. But people are actually harder than hardware. I said, yeah. So that's always a challenge. We're selling something new. No one has bought, very few folks have bought the technology that we're selling. And so we have to address that. And my last one is cognitive dissonance. For me to be successful, I had to learn to live with this idea that everything is going to work exactly as planned and nothing will. Once I kind of came to that realization, I was feeling pretty good. That's what I got. I see it looks like my time is coming to an end. That was my last.